Hello everyone, it's Mr. Wolfe here, and in this video I'm going to be explaining scenario 3 of the mini packet on hitting the longest home run ever, where we're going to be comparing the explosive bat, but the explosive bat with stops. So that means the piston fires, but then it gets caught, like it's still attached with the bat, or the explosive bat without stops, where the piston fires and then it keeps on pushing the baseball. All right, now ignore these animations that came here. I just forgot to put them in the right order, but I want us to focus on this one with the question mark right here. So our goal is to figure out how the change in velocity compares for the bat hitting the baseball with and without stops. Now, what I also like to do is look at the problem and say, okay, what things do I know from the problem? All right, I know the mass of the baseball from the problem, how those compare. I know how the force compares from the problem, and I know how the time of impact compares for the problem. All right. Now, one thing I don't know from this problem above is it doesn't say anything directly about the change in momentum. So I don't know that. All right. And if we think about the warm up, I can't figure out my change in velocity as an always true statement if I don't know my change in momentum as well. So what I'm going to do is I'm going to put this on hold and I'm going to try to figure out what my change in momentum is first using these two variables I know. So let's do that. So here I have with stops and without stops. All right. I'm going to kind of model this out visually. And I know that the forces between the objects are the same, all right? It's the same piston firing from the gunpowder, so same force, all right? Now, because the baseball bat doesn't have any stops, the time of impact, right, that piston pushing the baseball, even though it's milliseconds, it's still a way longer time of impact compared to without the stops, all right? So because of that, same force, all right, but because there's more time, we have a greater change in momentum as well. All right, so now, right, we've changed this question mark to something we do know. All right, and now that I know both my change in momentum and my mass, I can figure out what my change in velocity is. All right, so I know that the change in momentum, so again, I'm just kind of carrying this down. The one without stops has a greater change in momentum because I figured it out over here. And I know that the mass between the objects, the mass of the baseball is being hit, those are the same too. So if I have the same mass, all right, being hit, but this one has a greater change in momentum, that means that it must also have a greater change in velocity as well, all right? And so if the baseball has a greater change in velocity, that means it's going to go a further distance as well, all right? So if you want, you can pause the video, all right, and you can kind of make sense of the models if you need to, the explanations that come after looking at the models. And thanks for watching.